Hello, hello, hello. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Conco, New York, and there's my email address. If you don't understand what I'm saying, you can scan that QR code right there, and the genius who made this video will explain everything to you. Not the video, the worksheet. I'm making the video. And what we're going to be doing now is we're going to be doing some pretty powerful math right here. We're going to be doing quadratic inequalities in one variable. This is Common Core Algebra 2, and it is the non-regents. Okay, so right there is a classic head and shoulders chart of a stock. And you can see right here, they're calling that the breakout point. And so that is where the equation, the inequality is greater than 10. If you notice, there is some resistance level right here, right around 10, and then it hits 10 and breaks out and goes above $10 a share. So all of this has real world applications. At the heart of solving any inequality values is finding um, the numbers that make it true. The basic notion of inequalities is critical to understand before we proceed. So let me see. It says determine if each of the following is a solution to inequality given. Show work to justify your response. Well, there are two ways to do it. Number one, you can plug 4 in everywhere you see x and see what happens. Number two, you can graph them and draw a vertical line where x equals the number, so x equals 4, to find out if f of x is greater than, less than, or equal to 0. Okay, and why did I say 0? Because that's the 0 spot right there. I'll leave that there just for a second. I'm going to pull up the graphing calculator. I typed in the first inequality correctly. It's not an inequality. I typed in the first equation correctly. Now I'm going to change the zoom. And here it is right here. And so then we take a look at 4, x equaling 4. X is 1, x is 2, x is 3, x is 4. We draw a vertical line there. And now is f of x. F of x is the blue curve. Is f of x, it says, is it greater than 0? Okay. Is that greater than 0? No, it isn't. It looks like to be right around -4. So that is false. And I just did the arithmetic really quick and found out it is -6. -6 is not greater than 0, so it's false. So I prefer the graphing method. You can obviously do the algebraic method also. So I just graphed the second one, and this is x equaling 2, x is 2 is right there. And obviously it is going to be greater than 0. So it's true by graphing. For this one, why don't we plug it into the inequality? Remember that whenever you have a negative number, you have to put it in parentheses, otherwise you're going to get the wrong answer. Your calculator will lie to you and will say this is -9 when it's really 9. Plus 3 minus 12, is that less than 0? Is it less than 0? And 12 minus 12 is not less than 0 because 0 is not less than 0. Okay, so when we're looking for something, remember it's not equal to it. This has to be less than. It should be less than or equal to 0. And remember, make sure you have this copied down. Okay, that's the whole reason why we can graph. Most of the time, there are an infinite number of solutions to an inequality. Okay, so there's the difference between countable infinite and uncountable infinite. Most of the time, there's going to be an infinite number. The only time that it's not going to be an infinite is when there's exactly 1 or when there's exactly 0 solutions. The solution set of inequalities like these can be written in roster form where one lists the solutions. So they cannot be in a list because there's an infinite number of things. In exercise 2, we'll explore how to determine this solution set by using tables on your calculator. So here we go. Here's the inequality. So the first thing it says is to solve algebraically for all values of x. So let me see, we're going to use the zero product rule, where if the answer is 0, then one of these two things has to be 0. I don't see two things there. Don't you see two things there? Yes, let's factor it. x. One of them is going to be plus. One of them is going to be minus. And let me see, it's going to be positive 3 and negative 1. So x is negative 3 or x is positive 1. So I factored it and I solved it. I set each part equal to 0 mentally, and there we go. That's the shortest way that you can do that. And just for fun, I graphed it and confirmed the solutions, negative 3 and positive 1. See, negative 3 and positive 1. Got it. Now we hit the second and the graph key, take a look at the table, and it says fill it in from negative 5. So that's exactly what we do. Negative 5 goes to 12, and then negative 4 goes to 5, then a 0, and negative 3, and negative 4. Oh, now we have the turning point. 0, 5, and 12. So I'm going to get rid of this table. That was just the calculator sitting on the desk. And there we have the nice table that's filled in right over there. Explain why the zeros I found in part A are not part of the solution set of the inequality. Okay, let me see. It just said fill in the table. It didn't ask us to find the solution set to the inequality. But right now, I can see that, oh, that just says less than. It does not say less than or equal to. So that's the reason. There we go. Write the solution set to the inequality and represent it on a number line. Okay, so it says we want everything less than 0. So the y's are less than 0, right? This part, that's the f of x. That's the f of x, that's the y, that's the 0. That's the input, those are the x's. So what we're going to do is we're going to write all numbers x such that, now we notice it's in between. It's in between these numbers, okay? So I'm going to put my x in between the negative 3 and the 1. And since that isn't underlined, doesn't say less than or equal to, I do not underline those. And I close it. There it is. Now represent it on a number. So the fact that it's going to be in between, x is in between the negative 3 and the 1. So negative 3, negative 2, negative 1, 0, 1, 2. There we go. It's an open circle because it's not underlined. It's not an equal to. It's an open circle because it's not an equal to. And we can test 0. Is negative 3 less than 0? Yes. And is 0 less than 1? Yes. So the 0 side of it, we shade. 2. Is negative 3 less than 2? Yes. Is 2 less than 1? No. So we can't do it. Negative 4. Is negative 3 less than negative 4? No. So we just test each part. The key to algebraically solving a quadratic inequality is first find the zeros and then test points between the zeros like I just did and outside the zeros. Okay, which of the following is the solution set to this inequality? X squared minus 4 is greater than 0. This is a difference of two squares. Okay, you should immediately recognize it as a difference of two squares. So it's an x and an x. What two numbers multiply to be negative 4 and add up to 0? Oh, positive 2 and negative 2. If you're having a problem with difference of two squares, make sure you ask me in class. You really got to know that. So now x plus 2 is greater than 0, so x is greater than negative 2. X minus 2 is greater than 0, so x is greater than positive 2. So now we got a little bit of a problem here. The problem is that x is greater than negative 2 and x is greater than 2. Okay, so what we have to do here is solve it. X equals negative 2 and x equals 2, and then we're going to test. So let's just draw a quick little number line here. there's 0, there's -2, there's +2, there's 3, there's -3. Okay, so what you do is you just plug in 0. Uh, so that was a silly number. No, it isn't. There for a second I thought that I was making a mistake. So we plug it in, we plug 0 in. So 0 plus 2, 0 minus 2 has to be greater than 0. So 2 times -2 has to be greater than 0. -4 is not greater than 0. So we don't shade in the center. This is a no, you don't shade. So when we pick 3, we can pick 3, and 3 plus 2, and then 3 minus 2 has to be greater than 0. And so 5 times 1 is greater than 0. So yes, it's true. So we're going to shade open circle here. We're going to shade that way. And if we test the left-hand side, it'll be an open circle and shade that way. So our answer to the question is choice 3, where it's either greater than 2 or less than -2. So what did we do? We factored it to figure out where the critical numbers were. The critical numbers were at -2 and +2. Then we tested numbers in between that, to the left of it and to the right of it, to see which way we had to shade. We really didn't have to graph this inequality because it asked us, you know, which one of these is right. So, but the fact that I graphed it, I can read it better than the inequality. Let's take a look at the next page. Okay, so exercise 4 says to solve these. Each of the following quadratic inequalities, write your final answer in set builder notation. Okay, so the first thing I want to do is still factor it. So, we can go through the long thing and say what numbers multiplied by -36 and that have to be -5, and that would be x squared, and that would be -5x. And you think it's 9 and 4, 9 and 4. And, you can go through this whole process, but the fact that that leading number is a 1, we can do this a lot easier. By the way, it has to be -9 because I have to add up to be -5. There we go. So what am I talking about? I am talking about the fact that it can be x minus 9 and x plus 4. Okay. Since that's a 1, we can just take that number and that number, plug them in there. So this is x. Again, we're looking for the critical numbers, so I'm going to use the equal to sign. X equals 9 and x equals -4. Those are the critical numbers. So 9, there's 10, and here is -4, and that's a 0. So they're filled in. And they're filled in. Now we got to find out if it's going to be a center spot or the left and right side. So I'm going to take 0, plug it into the original equation. You can plug it into the factors. You can plug it into the original equation. So if I plug in 0 squared, minus 5 times 0, minus 36, is that less than or equal to 0? Yes. So I plugged in 0, so we know that it has to be shaded in between. And now the left-hand side, 10. So 10 squared is 100 minus 50 minus 36. Is that less than or equal to 0? No, it's 14. 14 is not less than or equal to 0. No. And then we check the left-hand side with -5, and we find out the same thing, that no, it is not. We read the question, and it says write your answer in set builder notation. And since I'm only going to do A and C here, we can write our set builder notation answer here. All numbers x such that, and you notice that we're shaded in between, so that means x has to be in between, -4 and 9. This is why I like graphing it. And we notice that it's filled in, so they're underlined, and we close our set builder notation. Now let's do C. First of all, I'm going to combine all like terms on the left-hand side, so I'm going to add 8 and subtract 10x. I am going to add 8 and subtract 10x. 2x squared minus 14x, and negative 8 plus 8 is nothing, has to be greater than or equal to 0. I'm going to take out a GCF of 2x. I'm left with x squared, x minus 7 is greater than or equal to 0. So either 2x equals 0, so x is 0, x minus 7 equals 0, so x is 7. Draw your number line and test it. So we have 0, we have 7, we have a number in between, and we have a number less than it. So remember, we cannot, 0 is a critical number, and it is less than, it is equal to, greater than or equal to. So 0 is going to be filled in, and probably 7 is going to be filled in. So why don't I test 5, plug 5 into it. So 50 minus 20 minus 8 has to be greater than or equal to 50 minus 8. This is 30, 22, has to be greater than or equal to 42. Nope. So that's a no. It fails. I'll take a 10 and plug 10 in. And we have 200 minus 40 minus 8 has to be greater than or equal to 100 minus 8. And it is yes. 152 is greater than or equal to 92. So it goes that way. And we can check negative 10, and we get the same answer. We get a true answer. Okay. So now write it in step builder notation. Sorry about that. I really hate going back into this area. All numbers x such that now it's going to be 0 is less than or equal to x, and or x is greater than or equal to 7, and then close it. If you have questions about that, just ask me in class. Let's take a look at what our homework is. And here's the homework. On the next 2 pages, we have problems number 1 and number 2, number 4, and number 5. Number 5, you should be able to eliminate a couple of wrong answers. Then on the next page, 7A, 7C, and 7E. Okay, that wraps up lesson number, what is this, 7? Lesson number 7. Hope you had fun. Make sure you ask me questions in class or after school. Thanks.